This video is for topic 5.6, reaction energy profiles. The objective for this topic is to represent the activation energy and the overall energy change in an elementary reaction using a reaction energy profile. So we can have very complex reaction energy profiles. In this particular reaction, our reactants are 2NO plus 2H2, forming N2 and 2H2Os. However, we have multiple intermediates, and so we have multiple parts to our reaction energy profile. Each bump or each activated complex represents a different elementary reaction. So we initially start with our reactants and we form our first round of intermediates, which is N2O2 and H2. And then we have another elementary reaction forming our next intermediates, which are N2O, H2O, and H2. And then finally, we have our last elementary reaction where we form our final products. And so each of these bumps in the reaction profile shows us our different activation energies required for each of the elementary steps. So we know that this reaction energy profile would match or correspond to a mechanism that has 3 steps to it because we have 2 different intermediates as part of our reaction. There is an equation that relates the rate constant to the activation energy, and that's called the Arrhenius equation. That's where K, which is our rate constant, is equal to A times E to the negative EA divided by RT, which we can also write as an equation of a line where the natural log of K equals negative EA divided by R times the inverse of T plus the natural log of A. So this equation relates the temperature dependence, the activation energy, and the rate all together. This is not something that you'll need to calculate. This is just something that I wanted you to be aware of, that there is a relationship between the temperature, the activation energy, and the rate. And there is actually a way to calculate it. We just don't have to.